Hello everyone, I'm Janvi. As you see on the screen, our today's topic is Deterministic Finite Automata. So the topics to be seen is introduction about DFA, formal representation and definition of DFA, acceptance of a string, and we would see the same with simple example, determinism and non-determinism, applications of DFA, and we would end with a simple conclusion. So I'm heading with a simple introduction. DFA, that is Deterministic Finite Automata, is a mathematical model used to represent and analyze systems with discrete inputs and outputs. It is widely used in computer science and automata theory. So DFA is mainly used to create automatas, that is machines, using the sum inputs and generating outputs out of the same. So let's go into the history of DFA. DFA was first introduced by mathematician and computer scientist Michael O. Robin in the late 1950s. It was further developed by other researchers including Edward F. Moore. The concept of DFA has become a fundamental concept in automata theory and is extensively used in various fields of computer science. So I'm moving towards a brief introduction about DFA. DFA, that is Deterministic Finite Automata, constitute foundational modules within the realm of automata theory, serving an abstract representation of computational machines designed for a language recognition. And the study of DFA emphasis is placed on their ability to recognize, accept languages where language consists of inputs which consists of string composed of symbols from a specified alphabet. A DFA process inputs symbols sequentially and at each step of transition between states according to the predetermined rules defined by the transition function. The core objective of DFA is to determine the acceptability or rejection of a given input string based on its final state. If a DFA arrives as an accepted state after processing the entire input, the string is deemed accepted. Otherwise, it is rejected. This deterministic nature of DFA, characterized by unambiguous states transition for each input symbol, form the basis of their application in various aspects of theoretical computer science, particularly in the design and analysis of algorithms, formal language recognition. I guess you have got some idea about DFA, so now let us look into formal representation and definition of DFA. In short, DFA is a mathematical model used for a system, that is to describe and analyze the behavior of a system that processes input symbols. It is defined by five tuples that includes Q, sigma, delta, Q naught and F, where each one of them represents DFA with their own particular functions. Q represents finite set of states that a DFA can have, and sigma represents finite set of inputs that is used to generate the required language, and delta is the transition function that maps the input symbol to the initial state to the next state. And then we have Q naught, it represents the initial state of a DFA, and F is a set of final or the accepting states which indicates when the DFA has been reached a valid state. So whereas from NFA, DFA has its own set of rules where the acceptance of string is deterministic, that is definite acceptance of a string. Accepting or rejecting input strings. A DFA accepts or rejects input strings based on current state in transition function. Accepting stage. In a DFA, an accepting state is a state that when reached after processing an input string indicates that input string is accepted by DFA. Language recognized by DFA. The language recognized by DFA is a set of all inputs that are accepted by DFA. So now let's understand the same with simple example. So our task here is to construct a DFA accepting all strings over the inputs A and B ending, and it must end with AB. So we must construct a DFA which might have numerous number of and multiple occurrences of A and B at the beginning of the string, but it must definitely end with AB at the last. So we could generate the language as same. So we have, so the language, it represents the language L, and this is epsilon, which represents anything might be there or nothing at the beginning of the string AB. So we are ending with AB, and then we have a single occurrence of A with an AB and B, which is followed by AB. So simultaneously we may get any number of AB and a mixture of AB at the beginning of the string. So, and it must end with AB at the ending. So the states required is 3, because we have two strings which is to be present in our transition diagram. So we would have 2 plus 1, that is 3 states, and our initial state is q0, and which is followed by 3 states, that is q0, q1 and q2. So have been shown this here, and then the input symbols, that is a and b. So the final state is q0, which has been doubly encircled. So firstly we are gonna represent ab, which is definitely needed, and according to our language basis, we are adding extra inputs to the transition diagram. So here is a theoretical explanation of a DFA with an example. A DFA is a mathematical model used to recognize patterns in input string. It consists of various components: states, input symbols, transitions, initial state, and final or accepting states. The DFA has a set of states which represent different conditions or configurations of an automata. Can be in input symbols. DFA input symbols, which are characters or symbols from the input alphabet the automaton can process. Transition define the behavior of a DFA, then specify how automaton moves from one state to another state based on the current state and input symbol. Initial state: the DFA has an initial state which is starting point of an automaton. It represents the state of an automaton before it processes an input symbol. Final or the accepting state: the DFA may have one or more final or the accepting states. When the automaton reaches a final state after processing the input symbols, it indicates that the input string is accepted by the DFA. So now let's understand the determinism and non-determinism in any transition diagram, that is in any automaton. So determinism, that is with respect to DFA, a definite automaton is a mathematical model used to represent and analyze systems with finite states and inputs. In DFA, each state has a unique transition for every input symbol, resulting in a single deterministic path for any given point. And non-deterministic finite automata represents the NFA. An NFA is a mathematical model that allows multiple possible transitions from a state for a given input symbol, or an epsilon transition resulting in multiple paths for any given input. NFA are more expressive but require additional mechanisms, such as epsilon transitions and set of states to handle the non-determinism of the transition. So now let's see the various fields where the DFA has been applied. It includes compiler design, natural language processing, network protocols. Compiler design. DFA are used in compiler design to analyze the process, the syntax of programming language. They help in tokenizing, phrasing, and generating intermediate representation of a source code. Natural language processing. DFA play a crucial role in language processing tasks such as text classification, sentiment analysis, and named entity recognition. They help in pattern matching and language modeling. Network protocols. DFA are employed in network protocols for tasks such as packet filtering, routing, and intrusion detection. They help in efficiency, processing, and analyzing network traffics. So now let us end with a conclusion. So before ending, let us recap. The key points: DFA are mathematical models used to solve problems, computer science and automata theory. DFA consists of finite set of states, input symbols, transitions, functions, and start and final or the accepting state. DFA can recognize, accept or reject strings based on a given set of rules and transitions. Thank you. I hope you found this presentation informative.